Your next lesson is on developing strategies for finding a shorter way to find the factors of numbers. So students will find factors of numbers up to 100 and determine whether a given one-digit number is a factor of a given whole number in the range of 1 to 100. So let's begin. We're going to start with a review of division. Let's talk about these few just as a review to get our brains thinking in division again. So you have four equations here. 15 divided by 3. So if we did 15 divided by 3, the answer is going to be 5, remainder 0. And I know this because I can skip count by 3s 5 times to get to 15. 16 divided by 3, the answer is going to be 5, which gives me to 15, with a remainder of 1 to get to 16. 17 divided by 3, you can't do evenly, but the answer is going to be 5, which gets me to 15, and then a remainder of 2. And 18 divided by 3 doesn't go in evenly, but we know that we can get to 15 by going to 5, and then a remainder of 3. So if I ask you, is 3 then a factor of the number 15? The answer is yes, 3 is a factor of 15 because it goes in evenly. There's no remainders. So is 3 that, are 3 or the number 5 factors of 16? The answer is no, because there is a remainder of 1. Are 3 and 5 factors of 17? The answer is going to be no, because we know this, there's a remainder of 2. It does not go in evenly. And then 3 and 5 we know are also not factors of 18 because there's a remainder of 3. So we notice that to use division, if we want to find the factors, there cannot be any remainders left. So if you have a remainder, automatically there cannot be there's no factors. So we know that 3 times 5 gives me 15, and we know that 3 times we can't get, or 3 times what gives me 18. We know that 3 times 6 is going to get me 18. So is 3 a factor of any of these numbers? The answer is yes. 3 is a factor of 15 and 3 is a factor of 18. So I want you to do these exercises on your board. So is 3 a factor of the number given to you? And you're going to be using division. So let's do A, for example, together. So we have sorry, we're not going to do long division yet. I'm jumping ahead. We're going to think of 19. So 19, can we do 19 divided by something to get to 3? Or sorry, can we do 19 divided by 3? The answer is no. If we skip count by 3s, we can never get to 19. 3, 6, 9, 12, 15, 18, 21. The closest I can get to is 18, and that would be 3 times 6. Then I need to have a remainder of 1 to get me 19. So therefore, I know that 3 is not a factor of 19 because there is a remainder. So I'm going to put an X here. I want you to do B and C on your whiteboards and see if 3 is a factor of 20 or 21. When you're done, you're going to continue on with your screencast. Now let's try these numbers. Is 4 a factor of the number? So can you do 18 divided by 4 evenly, or are there remainders? When you're done, you're going to continue on with your screencast. Now, before we go any further in this lesson, we're going to do a review of long division. So I have put our acronym here on the side just to help kind of trigger your memory. So we use the saying, dangerous monkeys swipe bananas. We first divide, we multiply, we subtract, and then we bring down. So we want to know if 364 can be divided by 7. So I know that 7 cannot go into 3. I need my 0 placeholder. Now I'm going to look at the number 36. Does 7 go into 36? Well, it goes into 35, so 7, it can go into 36 5 times. So 5 times 7 is going to give me 35. Now, according to our acronym, I'm going to subtract. 36 minus 35 is equal to 1. And now I'm going to bring down the 4. How many times can 7 go into 14? We know that 7 times 2 goes into 14. So I'm going to put 14 here, and I'm going to subtract again. The answer is 0. So I know that 364 divided by 7 is going to equal 52, remainder 0. Now, I'm going to ask you the question, is 7 a factor of 364? How can you tell? By looking at our long division equation that we just did. Well, we know that the remainder is 0, so therefore 7 is a factor of 364. Now, using long division, I want you to find if 3 is a factor of the number given. You're going to check with long division. Remember, you're looking for anything with a remainder of 0. That will tell you if 3 is the factor. When you're done, you're going to continue on with your lesson. So we're going to decide if it's better to use our skip counting strategy that we used before or the long division strategy to check whether 3 is a factor of 145. Which do you think is a better strategy? So if we're going to skip count all the way to 145 by 3s, it's probably going to be pretty easy to get lost and forget my place in skip counting with that many steps. That's a pretty far ways to skip count to get to 145. So for this one, I think the easier answer, and it's the faster answer, is going to be checking through long division. So we're going to check if 3 can be divided into 145. Well, we know that 3 cannot go into 1, so I need my 0 placeholder. 3 can go into 14 4 times. 3 times 4 is 12. I'm going to subtract, it gives me 2. Going to bring down the 5. And now I'm going to decide, can 3 go into 25? 3 cannot go into 25, but it can go into 24. So we have 3, 6, 9, 12, 15, 18, 21, 24. 3 times 8 is going to give us 24. Then I'm going to subtract 1 last time, and it's going to give me a remainder of 1. So I can see that 3 is not a factor then of 145 because there is a remainder of 1. That was pretty quick for me to solve using the long division strategy rather than skip counting all the way up to 145. Now I want to check if 3 is a factor of 14. So do you think I should use skip counting or should I use long division? Well, you're probably going to just skip count because 14 isn't a very far ways to go. So we could just skip count 3, 6, 9, 12, and then 15. Well, obviously 4 cannot be a factor then of 15 because it falls somewhere in the middle here. Pretty easy to solve. Wouldn't have been any quicker to do long division or to skip count for that one. But now if I want to know whether 3,000 is a factor of 14,000, am I going to skip count or am I going to do long division? So can I skip count maybe by 3,000 instead of 3s? Well, I can count on one hand how many times 3,000 goes into 14,000. So I would probably just skip count for this one rather than doing long division because I could just go 3,000, then 6,000, 9,000, sorry, those are zeros, 12,000, then I'm going to get 15,000. So is 3,000 a factor of 14,000? The answer is going to be no because it does not go in evenly. On your whiteboards, I want you to check if 6 is a factor of the following numbers using either the skip counting strategy or the long division strategy, whichever one that you find easiest for the numbers that you're given. When you're done, you're going to continue on with your screencast. We can also use the strategies of using a t-table or using a chart. So I made this chart here to find the factors of 28. But if you notice on my chart, It goes all the way to 14 and then to 28. But why on my examples did I stop here at 7? So I know 1 times 28 can get me 28, 2 times 14 is 28, 3 doesn't work, 4 times 7 is 28, 5 doesn't work, 6 doesn't work. Why did I stop here though? Why did I stop at 7? Well, after you reach the number that appears in the earlier pair, you're going to stop filling out the chart because, for example, if you have 7 pairs up with 4, if you flip this around, it's obviously going to be 7 and 4. So I don't really need to continue on with my chart any further. But on the other hand, a number that is not paired up so far won't pair up at all. So for example, 7 times 4 is 28, but 8 times something is not going to ever get to 28. So 8 would have to pair up with either 1, 2, or 3. It's not going to pair up with 4. But we've already checked those lower numbers of 1, 2, and 3, so we know that 8 doesn't have a pair at all. So I don't actually need to complete this chart any further to find the factors of 28 because I've already found them. I know that 1 is a factor, 2 is a factor, 4, and the 7, 14, and 28 are all factors of 28. I don't need to go any further. I want you to use this strategy here now, and you're going to complete a chart for the factors of 20 and 24 on your whiteboards. So again, you don't need to complete the full chart, you only need to go as far as you need to find all the factors. You can actually also even save time by writing only the numbers that are the factors. So instead of listing the numbers that don't work as factors in your chart like we did previously, you can save time by writing only the numbers that are. So here's some examples of charts that show this. So if we are looking for the factors of 15 here, we know that 1 times 15 is going to get me 15. We know that 3 times 5 is 15. And then all of a sudden, if I drew a line here on my chart just flips upside down. So we know that these two columns are going to be the same and these two, rows are going to be the same. The chart is just in reverse. So that all of the factors of 15 then are 1, 3, 5, and 15. We don't need to list the numbers twice. If I look here, we're trying to find the numbers of all the factors of 12. So if I look here, draw my line in the middle, the chart just flips around. So I can see that the factors of 12 are 1, 2, 3, 4, 6, and 12. Again, not listing any numbers twice. Then in this third chart, we have found the factors of 14. So again, here's the line where the chart flips. I know the factors of 14 are 1, 2, 7, and 14 itself. Now, using this method of leaving out the numbers that are not factors, I want you to list all the factor pairs of 16, and 21 in a chart. So again, just looking at this chart for the factors of 12, remembering that this chart always flips when you see when the numbers start repeating. So the bottom half of the chart shows the same numbers as the top, just in reverse order. So as soon as we find a number that's already part of a pair, you can just stop because they are going to repeat each other. You may also need to use long division to look for factors. And we know that when the remainder is 0, then the number is a factor itself. So here, just one more exercise before you begin your assignment. You're going to make a chart showing the factor pairs for the following numbers. When you're done, you can continue on with your assignment in your Jump Math book. Today's assignment is page 127 to 128. You're going to complete all questions and then check in with the teacher.